In this part of our lesson, we discuss the exceptions to the octet rule. Knowing that octet means that every central atom would like to have 8 electrons, sometimes we see atoms that need to expand the octets. And what that simply means is you'll see more than 4 bonds or more than 8 electrons centered around that middle atom. And how they can do that is simply expanding into some empty d sublevels that have more than 8 electrons. Another exception to the octet rule would include odd number electron species. For instance, nitrogen, who has 5 valence electrons, oxygen, who has 6 valence electrons. We can clearly see with a total of 11 valence electrons, there is no way to have everyone end up partnered, so we'll have one unpaired electron. It's just an exception to the generally accepted rule. Incomplete octets. For instance, boron, who lives in group 3A, will have 3 valence electrons. Same with aluminum, if it has 3 valence electrons. Boron and aluminum are the first 2 elements in the column 3A. It would clearly make sense that this will end up with just 3 bonds around it instead of the 4 that normally we would see. Here's a practice in assigning formal charges. To review, a formal charge, we take the group number, which is the normal number of valence electrons, minus each one of the electrons that are unpaired or unbonded, and half of the ones that are bonded. So let's model for carbon dioxide. The first oxygen lives in period 6. It has 6 valence electrons. There is 1, 2, 3, 4 lone electrons, unbonded, and half of the bonded one from each of these double bonds here. So here's 1 and a second. 6 minus 4 minus 2 gives us a formal charge of 0 on that oxygen. And since this is a symmetrical molecule, this one would also end up to be 0. Carbon, who lives in group 4A, it has 1, 2, 3, 4. It also has a formal charge of 0. The molecule itself ended up to have a 0 formal charge. Let's take a look here. H3PO4, formal charge on the hydrogen. 1 minus 1 is 0. It lives in group 1A. It has 1 electron from half of the set here, formal charge of 0. Same is true for that and for that hydrogen. Let's do the oxygen here in this line. Oxygen lives in group 6A. It has 1, 2, 3, 4, 5, 6. Formal charge here is 0. Let's do the top. Oxygen lives in group 6A. There's 1, 2, 3, 4, 5, 6, plus 1 from the bond is 7. This oxygen has a formal charge of -1. This oxygen to the right will match the one to the left, ended up to be 0. And looking down here, this oxygen lives in group 6A. There's 1, 2, 3, 4, 5, 6. 6 minus 6 is 0. Formal charge on this oxygen is 0. So they all worked out to be 0 except the one on top was a -1. How about the phosphorus? Phosphorus lives in group 5A. It has 1, 2, 3, 4 electrons assigned to it. It comes out with a formal charge of +1. Notice the phosphorus with a +1 and the oxygen with a -1 still balances overall to be a 0 for the molecule. And the practice continues. I'll just do one more example down here. We'll try nitrogen, or excuse me, it's nitrite polyatomic ion. Oxygen lives in group 6A. We subtract out 1, 2, 3, 4 non-bonded and half of the bonded. Formal charge here of 0. Nitrogen lives in group 5A. There's 1, 2, 3, 4, 5, giving it a formal charge of 0. Oxygen lives in group 6A. 1, 2, 3, 4, 5, 6. plus 1 of the non-bonded is 7, so this formal charge is a minus 1. Notice the formal charge on this ion matches the charge that it's carrying. Overall, it came out to be a minus 1. Formal charge for molecules work out to be 0. Formal charge for polyatomic ions will match the charge on the polyatomic ion. And you can continue practicing with those examples. And notice here you can, when ready, check your answers up above on the next slide.